Hey guys, this is our last video of Unit 1. This is 1.11. We're going to be talking about measuring matter. Okay, so this hopefully is a little bit of a review. Okay, Unit 1 is kind of basic science stuff that you've probably heard a lot of before, but we're coming back to review it, make sure we're all on the same page. There's four different things that we're going to talk about. We're going to talk about mass versus weight. We're going to talk about volume. We're going to talk about density. We're going to talk about percent error. So it might be a little choppy here. I'll explain it as we go in terms of where practice is and whatnot. But just bear with me. If you have questions, you can always ask. First thing, mass versus weight, guys. Mass is talking about how much matter, how much stuff, okay, something has. The matter that we're talking about in chemistry are atoms and neutrons and protons and all that kind of stuff. Where weight is a force, okay? Weight depends on gravity. Okay? Which is the force pulling on an object. All right? Toward Earth. So if you're on a different planet, okay, or like on the moon, your weight's going to be different, but your mass is going to be the same. These are directly proportional to each other. Okay, as mass increases, so does weight. So just something basic here. We really, guys, only work with mass in chemistry, so don't worry too much about it. We have the same mass. Like I said, whether we're on the Earth or the Moon, the different forces of gravity on each cause us to weigh more when there's a higher amount of gravity. So if you go to the Moon, you weigh less. That's why, like when you see the video of the astronauts, they can actually bounce and stuff because they weigh less. All right, so just kind of a basic thing. We use mass, so grams are what we measure mass with. So just keep that in mind. It's different than weight. Volume is the amount of space an object takes up. So there's a couple different techniques that we use for different ones, and we'll talk about them throughout. Liquids, guys, you've probably measured these before. We use graduated cylinders. Burettes, those are probably something new that we will get to later on in the year. Now here's something that you will fall into this trap with. We never use a beaker or a flask. Okay, we never use a beaker or a flask. They're not accurate enough, okay? So when you're asked to do something in the lab, and we're going to talk about it throughout the year in our discussions, we always use a graduated cylinder because they're much more accurate. So regular solids, meaning you can take dimensions of them. You would measure those dimensions. This is what you talk about in math, okay? We use, that's an and sign. Shoot, I wrote the wrong thing. Length times width times height, okay? So if there's something like a rectangular shape, okay, a square, a cube, something like that, you can use length times width times height. Most of the time, though, we won't have something that is that neat and easy. So we will measure what are called irregular solids. That's what we use water displacement. Okay, something you probably are familiar with a little bit, but that's where something like, think about it this, when you ever get in like a bathtub, right, the water level rises. Well, that's exactly where that comes from, is that you're displacing water, and we can look at the different volumes that way, that it's displaced. So like our Penny Lab, that's what we used for that. Okay, so just keep that in mind. Liquids, we use graduated cylinders. Even irregular solids, we're going to use those, but we're going to see how much water is displaced or moved when we put a solid in there. Density should be a review for you. Mass, amount of mass in a given space. It's a ratio. What's a ratio? This is something we're going to talk about, and we're going to use ratios all year long, guys. It's just a comparison. It's a comparison of mass to volume, okay? So table T, it gives it to you in your table. It defines it for you as well, so it's mass over V. Maybe many of you guys remember this little helpful tool, the density triangle, okay, which is something that's very, very helpful, because if you're looking for, let's say, mass, okay, you would cover up mass. Oh, there's your formula. Mass equals density times volume. If I was looking for density, oh, look, it's mass divided by volume. If I'm looking for volume, I cover up that mass over density. So that's a useful tool. I would encourage you guys to write it on your reference table next to density, to kind of remember that throughout the year. So let's take a look here at this box. Box A or box B, which do you think has a higher density? Box A. Why would box A have the higher density? Well, take a look, guys. Remember, density is the amount of mass in a given space. We have more particles in box A in the same amount of space, therefore it's going to have a higher mass and it would have a higher density. Okay? So A, because more particles equals greater mass. So, reminders, guys. Volume can be calculated with length times width times height, like we said. This is a big one. That's why I put it in highlight for you. 1 liter equals 1,000 centimeters cubed. 1 milliliter equals 1 centimeter cubed. And we proved this, guys, with our little ruler activity with the cubes. Okay, so remember that. And then because volume changes with temperature, temperature is given with density. Okay, because volume can change. We'll talk more about why that is later on in the year. So here's some density problems, guys. I'm not going to really spend too much time with them, okay? But let's take a look at example 1. Okay, it says what's the volume? So we're looking for V. So think about your density triangle, right? So mass on top, density times volume on the bottom. Cover up that V to get your formula for volume. So our formula here, and we could solve the equation, or this is just a quick way, mass divided by density. So we have the mass, 25 grams. Ooh, but we don't have the density. But here's our clue, lead. And this is something, guys, that you're going to have to remember throughout the year. Table S is a huge table of constants, okay? Huge, huge, huge table. So we would look for lead on table S, and we would find its density. When you look it up, it's 11.3 grams per mil. All right, so we just have to do the math. Grams will cancel out. Mils will be our unit that we're left with. 25 divided by 11.3, 2.21 milliliters. Okay? So that's one type where you'd have to look up the piece. Remember, guys, you're only going to ever have to solve an equation for one variable. If you're missing 2, chances are it's in your reference packet, the piece that you're missing. Example 2, it says, what's the density? So we know right away our density formula is D equals M over V. Okay? Cover up that D. What's left? There's our formula. So we have a mass. Oh, it's scientific notation. 6.25 times 10 to the 5th grams. Ooh, but what about our volume? Are we given the volume directly here? No, but we're given its linear measurements, so we can multiply those together. So if you take 92.5 times 47.3 times 85.4, you would get 373646.35 centimeters cubed. Then you can just plug that into your calculator, and you would get an answer of 1.67 grams per centimeters cubed. Units. You got to make sure, guys, that you have your units in the end of a problem. If you don't, you will lose points. So this practice 8 is dealing with density. I'm not going to go over this right now. You can pause the video and do the practice for this now, or I'm going to continue on and talk about the last type of measurement, and that's percent error. Okay? So percent error, guys, it's the measurement of the percent that the measured value is off from the accepted value. Okay? Now, this term measured could also mean your value because you measured it. It could also be referred to as experimental. Okay? The accepted value, another term you could see, is the true, or the given, or the correct, or the actual. Those are all terms that mean the same thing. They're synonyms, so be on the lookout for those. So our measured value is the value that you get from doing a measurement, and this accepted, okay, that's the value that you should get. So think about it in terms of a bullseye, right? If you're playing darts or something, or you're shooting at a bullseye, you're trying to get to that, center point. That's the accepted value. But let's say you're off a little bit. That would be your measured value. Guys, this formula is not one that you have to memorize. It's on table T as well. We're going to write it here so you get used to it. So percent error equals the measured minus the accepted all over the accepted times 100. Make sure when you're writing a formula, guys, that you show it. When you show your work, you've got to have this times 100 or else you could lose points on the regents. Now, a lot of times this is absolute value here. It doesn't matter, guys, if the measured is first or the accepted is first on the top. I typically will just do the bigger number first. The big thing you got to remember, though, is that the accepted value goes on the bottom, okay? So if you get a negative percent error, your measured value is less than. That just means you came up short. Okay, that's all that means, is that you're less than the accepted value. If it's a positive, okay, percent error, that means that your measured value is greater. That means you shot too high. Okay? It's very important that, guys, that you put the given values in their proper place in the formula. Otherwise, you could get them wrong. So we'll do one example together, and then you guys can do a bunch of practice. It says, in a lab experiment, you're told by your teacher that the correct amount of sugar, notice there's that, in Coke is 39 grams. The mass of sugar is 40 grams based on your data. Okay, so here's the correct or accepted. And as I read through a word problem, guys, this is just a good technique to keep things organized. So this would be my measured value. What's the percent error? So now we figured out our pieces. It's just plug and chug from here. So I'm going to write out my formula. Measured minus accepted divided by accepted times 100. So my percent E is going to be 40 minus 39 divided by 39 times 100. So again, order of operations, guys, is going to be crucial. You have to do the subtraction first. Think about it in terms of parentheses, right? PEMDAS. Got to do parentheses first. So when we get our final answer, you should end up with 2.6%. Typically, guys, anything less than 10% is considered to be good. Okay? So, you guys can go ahead and rework and do this extra practice and check your answers in class. If you have questions, ask me. I'm here for you, and I'll see you guys in our next unit.